how to calculate the relative atomic mass of an isotope. When you talk about isotope, I'm talking about some element that have more than one atomic number. Don't forget, I said isotope is of an element is when an element have a particular same atomic number but different mass number, like you can see in the chlorine having different mass number. That is isotope. How do we now calculate their atomic mass, relative atomic mass? So let's look at this question. Calculate the relative atomic mass of fluorine. With Cl 1735 of 75% and Cl 1737 of 25%. Now here we want to calculate the relative, and I said relative here is just like what? Calculating the average. When an atom is having two different mass number, we can get their average, and that's what we mean by what? Calculating relative atomic mass. And it's common to isotope element that is in the form of isotope, that is having two or more mass number. Okay, so it will be what we do is we are going to take their mass number. For this first one, the mass number of that first one is 35. Look at 35 multiplied by percentage composition of that element, which is percentage composition of the fluorine 35 here is 75%. It's going to be 35 times 75 over 100 plus the mass number of the second one, which is mass number is 37, multiplied by percentage composition of this composition of the chlorine. 37 here is 25%. That is 25 over 100. We want to get their relative atomic mass because it's having mass number 35 and mass number 37. What would be their average? That's what I mean by relative atomic mass. So you can see we don't touch atomic number. Why? Because they have the same atomic number. The only difference there is their mass number 35 and 37. We want to get their average. So that is why the mass number of chlorine is always decimal point. So let's cut. You can say 77, 25 here, 25 here 3, 25 here 4. Here 25 here 1, 25 here 4. So here we have 3 times 3 times 35 over 4 plus here we have 37 over 4, and if I multiply, this one should give me 105 over 4 plus 35 over 4. So let's find the LCM. So LCM here is 4. So we have 105. 4 in 4, 1 times 105, I have 105. Here 4 in 4, 1 times this, I have 35. So if I had, this one should give me 140 divided by 4. And if I divide 4 in 14, I will get 3, which is 20, remainder 4. 4 in 14 is 3, which is 12. So remainder 2. I bring that 2 here, that is 20. 4 in 20, I think I will get 5. See 5. 2 decimal points. Sorry, there's a big 6 somewhere. Okay, this one is 37. I wrote 35. So this one is 35. 3 times 35 is this over 4. Here is a 37. Here is 1. This one should be 37, not 35. This one should be 37. So it's 37. So 37 plus this should give me 142. 142. So for here we have 3, which is 12, remainder 2. Bring that to it, that's 22. How many 4 will you find in 22? We are going to get 5. That is 35. That 5 is 20. Remainder 2 again. So 4 and 2 cannot go. I put decimal points. Put 0 behind that to 20. So if you keep on giving me 5, 5, 5, 5 like that, and it can now say 35.6. So gram per mole. So we can see now that that's why chlorine is having a negative decimal relative atomic mass. That's why it don't have a whole number. So if you want to approximate, it's 35.6. That's the relative atomic mass of chlorine. So let's calculate relative atomic mass of chlorine is 35.6. Okay. Let's look at another example. Let's look at another example of relative atomic. We can calculate relative atomic mass. You can see here. Or let's look at another one, which is calculating the percentage by composition. How to calculate percentage by composition of an atom in a particular, of an element in a particular compound. If you have to calculate percentage composition, how to calculate percentage composition of an element in a compound. How do you calculate percentage composition of an element in a compound? So let's look at this particular compound here. For example, let's look at this example. This example you can say calculate the percentage composition of by mass. Calculate the percentage composition by mass of let's say of oxygen in each of the following compound. Each of the following compound. Yes, first one, let's look at H2SO4. 2 CaOH bracket 2. To get any composition, you need to first get the relative molecular mass of each phase. So the first one we have H2SO4. So let's get our relative molecular mass. Or let me write relative molecular mass molecular mass will be equal to H, that is 1, times 2, because we have 2 atoms of hydrogen here plus sulfur here is 32 plus oxygen here is 16 times 4, and that one give us 2 plus 32 plus 64. And when you add that, 2 plus 32, that is 34. 34 plus 64, and that is 98 gram per mole. That is molecular mass. So now see percentage of oxygen now, of oxygen O will now be mass of oxygen here over total relative molecular mass times 100. And what is the mass of oxygen here? Oxygen here is 64. So it's going to be 64 over total relative molecular mass, which is 98, times 100. So it's going to be mass of particular something you are talking about over total relative molecular mass multiplied by 100. So multiply by 100, so you're able to give us the. So if you want to cut, I can model for this, and so here I have 32, here I have 48. Cut again, here I have 16, here I have 24. If I use 8 to cut again, 8 here 2, 8 here what? 3. So I have 2 over 3 times 100. 3, how many do we have? 5 in 2 cannot go 0. In 20, I have 6. I think I'm going to get 666. I can say maybe 667 times 100. So, and that one going to give me 66.7%. So percentage of oxygen here is 66.7%. Okay, for the second one, which is CaOH bracket 2. Let's get their relative molecular mass. Relative molecular mass will be equals to calcium is 40. Here I have 2 into bracket because of these 2 attached here. I took into bracket. What is oxygen? 16. What of hydrogen? 1. And if that's 40 plus 2 times 16 plus 1 is 17. So it's going to give us 40. What is 2 times 17? That is 34. 34. So you have 34. 34 plus 40. That is 74 grams per mole. So after getting that, let us now see how we can get our percentage. Percentage of what? Of oxygen. Will be what's the number of oxygen there? You know what we have here is O. This O here is times 2. Then we have O2 here. This A22, the O2. And what is O2? O2 here is going to give us 2 times 16, which is 32. So it's going to be 32 over total over 74 times 100. So percentage of oxygen there will be that number of what? Oxygen over that of relative molecular mass times 100. We do that. So let's cut. You can say 2 here 16, 2 here 37. So you have 16 over 37 times 100. 16 divided by 37. So that one will give us 0.4324 times 100. Now I'm going to give us 43.24%. So that is what? Percentage by mass. So we are going to just look at number of mass. You can see there over relative molecular mass multiplied by 100 give us percentage by mass of an element in the compound.